Hi everyone, myself Harshit Kalra and I am pursuing BTech in Electrical Engineering at IIT Ropar, and this is my project on greenhouses. A greenhouse is a special structure that is designed to regulate temperature and humidity of the environment in which plants are placed to grow. These cover generally a large area and are covered with a transparent sheet material on the outside to allow only sunlight to pass through it. They allow only negligent amount of infrared waves or heat waves to pass through them. In recent times, there has been a larger shift to greenhouses because of the automation of greenhouses. These automated greenhouses serve multiple purposes such as year-round growing, climate control, and increased exposure to light. But here comes the question that do we actually need automation of greenhouses? In order to answer this question, we'll look onto the several factors that govern the healthy growing of plants, which are light, temperature, humidity, nutrients, and soil moisture. But controlling all these factors manually and also with great precision and accuracy with industry perspective is practically not possible. Hence, a automatic greenhouse helps us to control temperature, climate and irrigation system all depending on the need of plant. It consistently monitors all the governing factors and takes necessary steps accordingly all by itself, that is automatically, and hence the automation of greenhouses is totally justified. This automated greenhouse reduces labor cost, improved yield and better growth of plants. In order to serve all the purposes, a greenhouse uses several sensors. Here I will be discussing only those sensors which I have included in my model. First is the light dependent resistor, LDR, or a photoresistor. In a greenhouse, during the daytime, sunlight is a source of light, but what about the night? Hence, LEDs are used to provide light during the night, which ensures a better yield of plant because plants are exposed to light during the night as well as day. Now, in order to serve this purpose, light dependent resistors or photoresistors are used. They sense the intensity of light falling onto it, and on the basis of it, they change their resistance, which indicates that these photoresistors have a dynamic resistance. Now, this is the image of a LDR or a photoresistor. The second sensor which I have inculcated in my model is temperature and humidity sensor. In a greenhouse, climate is a very important aspect, as the greenhouses traps some amount of heat and making it hot for the plants to grow and reverse during the night. Hence, temperature and humidity sensors are used to regularly monitor temperature and humidity inside the greenhouse, and depending upon the various values of temperature and humidity inside the greenhouse, cooling systems are turned on and off accordingly. This is an image of DHT11 temperature and humidity sensor. Now at last I have used soil and moisture sensor. Soil is very important in plant growth as it is a source of nutrients, minerals and water, all the important aspects that are required for the growth of plants. So maintaining the moisture level of soil and operating irrigation system accordingly is very important. Now in order to serve this purpose, soil moisture sensors are used. They work on the principle that mineralized water is a good conductor of electricity. When the moisture level in the soil is high, it means more conductivity or vice versa. These devices regularly monitors the moisture level of the soil and operate the irrigation systems accordingly. This is an image of a soil sensor, soil moisture sensor. Now I'll begin with a simulation of my project model. I am using online available TinkerCAD software for the simulation of my project model. In the circuit, I have included an Arduino Uno R3, which is a microcontroller, 3 LCD displays, one as an intensity monitor, other as a temperature monitor, and the third one as a moisture monitor. I have used a breadboard for solderness connections. When it comes to sensors, I have used a moisture sensor, a light dependent resistor, a temperature sensor, and a potentiometer, which I am using as a humidity sensor. Because TinkerCAD does not support a specific humidity sensor, I have used a buzzer to produce the sound of pump, a 10 kilo ohm resistor which is in series with LDR sensor to complete the voltage dividing circuit, 3 SPDT relays. I'm using a LED bulb, a pump motor and a fan. I'm also using 2 different LEDs, one green color and other one as a red color, both in series with 330 ohm resistors. Now I'll start with the simulation process. You can see that all the 3 different LCD display will turn on. On the first LCD display, you can see that the intensity being recorded by LDR sense is currently 0 and the bulb is on. On second LCD display, you can see that temperature is 24.7 degrees Celsius and the moisture level or the humidity is 46.04% and the fan is on. Now on the third LCD display you can see the moisture of the soil is 0.00% and plants are being watered, which is visible through the RPM value on the DC motor and also through the buzzer. It is also evident. Now I will increase the moisture level in my moisture sensor. You can see that when it will be sensed by the moisture sensor, the motor will turn off. The moisture level in our soil is increased to 74.58% and the motor is turned off. No water. Like I'll try to increase the humidity. It is now decreased to 20.04% and the fan is turned off. You can also see on the DC motor. If I increase the humidity level, the motor should turn on, the fan motor. It is increased to 75.95% and the fan is now turned on. You can see the RPM value on the fan motor. And also if I change the value or the light intensity following on LCD display, like I increase the intensity of light on the LDR and you can see that it will now turn off. The intensity is currently 0.00 lux and now it is increased to 0.29 lux and the bulb is turned off. If I decrease the intensity of light following on LDR, then it should turn on. Now it is decreased to 0.08 lux and the bulb is now turned on. If I try to change the temperature value, like I try to increase it, you can see that on a temperature and humidity monitor, the value of temperature should change. On temperature and humidity monitor, the value of temperature is now changed to 115.20 degrees Celsius and fan is currently on. If I reduce the value of temperature and also the humidity value, then you can see that the value of temperature is now reduced to minus 13.83 degrees Celsius and humidity is also reduced to 13.98% and fan is now turned off. If I increase the value of temperature, then temperature is now increased to 75.12 degrees Celsius and humidity is currently the same 13.98% and fan is now turned on. This is the entire simulation of my project model, and now I'll explain the qualitative view of the code that is governing this whole. I firstly introduced the liquid crystal library, I2C library, liquid crystal underscore I2C library for my 3 LCD display, L monitor, T monitor, and M monitor. Firstly, I have set a different variables for my 3 different sensors: humidity sensor, temperature sensor, and LDR sensor, which are governing the different values being sensed by the different sensors. I have set 3 different relay pins: relay 1 on D2, relay 2 on D3, relay 3 on D4. I have set up my LED pins on D5, red LED, and green LED on D6. The buzzer pin is set to D7. I have also set up for the smooth functioning of my program 3 different variables with constant unsigned long and 3 other different variables with unsigned long data type. In the void setup, I have firstly set up my LCD displays with 3 different functions: dot init, dot clear, and dot backlight. Dot init sets up the LCD display. Dot clear clears the LCD screen and sets the cursor to 0,0 on LCD display, and dot backlight turns the backlight of LCD display so that the content on it is clearly visible. I had set up my temperature sensor pin as input pin, LDR pin as also input, and moisture sensor pin also as input. All the other things like relay, LEDs, and buzzer pin are set as output pins. I am recording the current time through the millis function in the void setup loop, and I have also written 3 different functions for LDR sensor, light sensor function. For humidity sensor, I have written the function get temperature humidity function, and moisture level function for recording the value of moisture sensor. All these functions operate in such a way that the light sensor senses the value after every 250 milliseconds, humidity function senses the value after every 370 milliseconds, and moisture sensor senses the value after every 500 milliseconds. and reports the change accordingly. Now, in the temperature sensor function, in this part of the code, I have computed the value of the humidity and temperature mathematically by considering what are the values that are being recorded by the respective sensors. This line of code is just an interactive user interface visible on the temperature monitor, and the threshold value of temperature and humidity sensor is such that when the temperature is greater than equal to 45 degrees Celsius and humidity is less than equal to 30%, then the fan is turned on. And other way, when the temperature is less than 45 degrees Celsius and humidity is less than 30%, the fan is turned off. Now here comes the light sensor function. In the light sensor function, in this part of code, I have introduced all the variables and computed mathematically all the necessary things that are required to compute the intensity. The relation which I have used for relating intensity and resistance of LDR is intensity into LDR is equal to 1. This is an approximate relation. Now this is the line of code that governs the things visible on L monitor. Now the threshold value of the LDR sensor is such that when the intensity will be less than or equal to 0.17 lux, then the bulb will turn on or the relay one will switch from NC to NO. And when the intensity level is greater than 0.17 lux, then the relay one will not switch and the bulb will remain turned off. And the intensity will this is the case when intensity is greater than 0.17 lux. Now at last, for the moisture level function, I have set up two different variables, m value and m percentage, which are being used to compute the value of moisture in the soil, moisture percentage level in the soil. This line of code isn't just governs what is being visible on the LCD display. The threshold value for the moisture sensor is 40%. This means then the moisture level is greater than 40%. The pump will remain off and the buzzer will also remain off. In this case, the red LED is turned on and green LED is turned off, indicating that the pump is not being operated. On other way around, if the percentage of moisture is less than 40%, then the red LED will turn off and the green LED will turn on, indicating that the pump is on and the buzzer, which is the sound of the pump, is on. And in this case, the plants are being watering plants. Now here I come to the end of the simulation of my project model and also the code governing it. I have explained the code, just the qualitative view of it, and here I come to end of my project model. Thank you.